I'll now run ls-l in the normal way, and if you notice, the column immediately following the permissions is a column that contains mostly ones. That column is called the link count, and it tells you how many links are in existence for that particular set of data. For example, there is a file there called sample.html, it's third from the bottom. That has a link count of 1, which I can then use to assume that that name of the file, sample.html, is the only name for that particular set of data. However, if I look a little higher than that, I can see there's a file called cat. There's also a file called dog. Each of those has a link count of 3. That means that, for example, with the file called cat, that cat is just one of 3 names that that given file has. Where are the other 2? Well, they could be anywhere. It's often very difficult to tell. Note also that down towards the bottom we've got subdir1. Subdir1 has a link count of 2. Every directory that you see on the system will have a link count greater than 1. There is always at least one more link to a directory than the one that you can see. Can you think what the second link to subdir1 might actually be? Well, what if I go into subdir1, cd into subdir1, and do an ls-ld of dot. Look at the information that comes up. Compare that to the line, the second line from the bottom in the above listing. You can see that the permissions are the same, the link count is the same, the owner and the group are the same, the size is the same, and the date is the same. The only thing that's different is the name. One is called subdir1 and the other one is called dot. Remember I told you earlier that every directory that gets created has a little file in it called dot, which is an alias to the current directory. Well, now we can learn the technical term. Dot is just a link. It's a link that is automatically created for every directory. Why is it created? Just for convenience. So we are indeed looking at both of the links to subdir1. In the course directory, the directory is known as subdir1, and inside subdir1, the directory is known simply as dot. 2 different names for the same entity. Now, you may have already noticed that cat and dog in this particular directory both have the same permissions, the same link count, the same user and group, the same size, and the same modification date. Are they the same file? Well, they might be. Or it may just be a coincidence. They may just happen to have all those things being the same. So how can we determine whether both of those files actually refer to the same data? Or, I'll put it more correctly, both of those names refer to the same data. Are those 2 files both links to the same thing? How can I determine that? Well, I've already given you the tools to know how to do that. You just have to think of it. Okay, well I'll show you. I'm going to use the ls-i option, which lists the inode number. Clearly, if 2 files are actually referring to the same data, they have to share the same inode number. I use li, so I get a long listing, including the inode number. Whoops, I find myself in the subdir1. I'll try that again, ls-li. Better. Now, let's look at cat and dog. They both have inode number 2,662,370. They both have the same inode number, and that means absolutely guarantee that they are the same file. Which of course means that if I modify one, I modify the other. But if I delete one, the other one is still there, just with a diminished link count. Let's prove that. I'll just remove one of them. I'll remove dog. And I'll do an ls-li again. And I find that cat is still there, but its link count has gone down from 3 to 2. So there still is another link to cat somewhere around the place. And you may recall from an earlier example that it was the file called fish in the subdir1 folder. What if you didn't know where that other link was? What if you looked at the link count and it said 17 and you go, oh gosh, where are the other 16 links? Is there any way of finding out? Well, the answer is there is no really simple way of finding out. You can do it. It's actually quite easy to do, but there's no simple program that you just plug in an inode number and it tells you what all the links to that inode number are. You have to use the find program. And instead of, say, finding a given named file, you search for a given inode as follows. You type in find, followed by the directory in which you want to find, and then you specify the inode number using the inum flag. So which directory do you choose? Well, you would probably choose the root directory, unless you knew for a fact that all the links to that file were in a given subdirectory. So let's have a look at an example of that. So I might type find and then /. Now I don't really want to search in the entire Unix file system because that would probably take me a quarter of an hour or something, so I won't. I'll just search in the current directory because I do happen to know for a fact that all the links to that particular file are in this subdirectory. And then I'll specify an inode number of, what is it, 2662370. And that will hopefully list for me all the inode numbers in the current subdirectory or any of its subdirectories that have that given inode. And I find that there are in fact 2 of them. Now I've found 2, and the link count tells me that 2 is the total, so I must have found both of them. I could remove one of them. I could remove subdir1/fish, and now I do an ls-l, and I find that the link count for cat has gone down by 1, but the file is still actually there. And now I could do an rm of cat, and that is the first and only time that the data in cat actually gets deleted. Just to prove that, I'll do an ls-l again, and it has completely gone. You don't see cat there with the link count of 0. Okay, so that's an understanding of how links work. In the next module, we'll look at how to create our own links.